Okay, hopefully you had a chance to look at solving the rational equations when we were just doing cross multiplying or cross product rule. From the worksheet, you would have had, I believe it was 1, 2, 5, and 6 were the problems that you were supposed to, no, 5 and 7, sorry, that you were supposed to solve. We use cross multiplying when you only have one fraction on either side of the equation. Okay, today we're going to look at another method for when you can solve rational equations. And this one we're mainly looking at when you have multiple fractions on one side of the equation. Okay, so this one is using the LCM method, so that's your least common multiple. We looked at this process. You go back to week 2 when you were adding and subtracting fractions. In order to add and subtract them, you had to get the denominators to be the same. So to figure out what the new denominator of your fraction needed to be, you used this least common multiple method. So we're going to use that same process, except the only difference now is you have an equal sign in the equation that you're solving. So steps are simplify the problem if needed. So if there's any way that we can cancel or factor out stuff, we're going to try to do that first. Then you need to find your least common multiple. And you need to multiply the entire equation by your least common multiple. Okay, our goal for this one is to get rid of fractions when we're solving for x. So we're going to multiply everything by our least common multiple, and then we'll simplify and we'll solve for x. So we're going to look here first at this equation. First things first are always listing any excluded values. In this case, we have only x on our numerator. So we don't have to worry at all about figuring out excluded values. Then if you want to on the side, we can list to figure out our least common multiples. We have 3 different denominators. Okay, if a number does not have a denominator like this 4, it's easier to just write it as over 1 so that we can see that it's a fraction. Okay, when you prime factor each of these, it's just going to be whatever number is written. So your least common multiple, we need a 3 from everything. So I can cross off the 3's, and then we need a 1, which will just mean that it's a 3. So every single term, okay, terms are things added or subtracted together, needs to be multiplied by this least common multiple of 3. So this term gets multiplied by 3, this term by 3, and this term by 3. Our goal of this step right here is that when we go to simplify in our next line, everything is on one line. You don't have any fractions involved anymore. Okay, so let's simplify that first one. Your 3's cancel out and you're left with an x. Your second one, the 3's will cancel out again. You're just left with a positive 2. And then 4 times 3 is 12. Now that everything's on one line, you can go ahead and solve for x. We subtract 2 from both sides. X equals 10. All right, so we use this process when we're adding or subtracting. Notice that there were 2 fractions on this side of our equation, so you can't do the cross multiplying. Let's try another one. Okay, this one is similar to the one that we just did, so why don't you guys go ahead and pause this, and then you can check back and see if you can get the same answer that I have. Okay, so hopefully you paused the video and tried this on your own. When we wrote all of our denominators, we had 3, 2, and 1, because that 5 is over 1. Your least common multiple then, there weren't any that repeated, so I needed a 3 times a 2 times a 1, which means I needed 6 as my final least common multiple. So every term gets multiplied by 6, so now I'm going to go ahead and I'm going to simplify. 6 divided by 3 will leave 2 on my numerator, so then I have 2 times x. 1/2 times 6, those 2 and the 6 will cancel out, and that just leaves 3. So 3 times 1 is 3. And then 5 times 6 is 30. Now I'm going to solve for x. I subtract 3 from both sides. I have 2x equals 27. Divide both sides by 2. X equals 27 over 2. Okay, and I didn't need any excluded values in this one because I have no x or any other variable on my denominator. So hopefully you guys got that one. First thing you always want to do is your least common multiple. We're going to look at a few more examples. They're going to get a little bit more difficult. So if you need to, pause the video and go back and watch this problem or the problem before it to make sure you understand these concepts first. All right, our next one here, still very similar, but let's go ahead and list. We don't have any excluded values, so let's list our denominators, 2, 5, and 10. So 2 as a prime factor is 2, 5 as a prime factor is 5, 10 is 2 times 5. So when I do my least common multiple, I need a 2, so I can cancel out any 2's, and I need a 5. So that means my least common multiple is 10. Everything now gets multiplied by 10. Then I'm going to simplify, so I have a 5x plus 8x equals 3. Okay, so now go ahead and solve for x. 13x equals 3. That means x will equal 3 over 13. Okay, again, pretty straightforward with that one. These next two examples, though, are going to add in a little bit more factoring and different types of denominators. So this is our problem that we have here. Okay, first thing we want to do is we want to factor. So we already have a factor here. I'm just going to put a parenthesis around them so I can see it. Now I'm going to factor this one here. So I'm seeing what numbers multiply to a negative 4 and add up to a negative 3. So I need a negative 4 and a positive 1 will multiply to a negative 4, and that adds to negative 3. So my factors are negative 4, positive 1. Okay, I'm going to cross off this denominator just so that I can focus on what that's going to be. I do need to list my excluded values. Because I have a few factors that repeat, I only need to include that once. So I have when x minus 4 equals 0 and when x plus 1 equals 0. So x cannot equal 4 or negative 1. All right, now I can go ahead and I can list my least common multiple. So I have two kinds of denominators here. I have an x minus 4, x plus 1, and then I have the x minus 4 times the x plus 1. So just like we did with the numbers in the previous examples, we're going to list all the factors. X minus 4, so I can cancel this one out, and I can cancel this one out. And then I have an x plus 1. And that takes care of all of my factors for all of my denominators. So now, every term needs to be multiplied by x minus 4 and x plus 1. Okay, this involves a lot of writing. I like to just kind of put them up in the corner so that I can make sure that every single term is getting multiplied by my least common multiple. Okay, and then you can go ahead and you can cancel out whatever you can. And then we are going to simplify. Keep whatever factors that you have in a parenthesis as you go to solve this. X times x plus 1 plus 1 times x minus 4 equals negative 1. That's what I'm solving now. Okay, notice that this term over here, both of my factors for my least common multiple were able to cancel out. So go ahead and solve for x. Okay, so I got down to this line here when I was solving for x. Okay, because I have an x squared when I go to simplify, that's a key to me that I'm going to need to do some type of factoring. So I have the potential actually to get two values for x. So I brought all of my numbers and terms to the left-hand side of the equation. I'm now going to factor. I'm seeing what numbers multiply to negative 3 and add up to 2. So that would be a positive 3 and a negative 1. We'll add up to a positive 2. So my factors then become x plus 3 and x minus 1. Now I'm going to set those equal to 0, each factor, and solve for x this way. So I have x equals -3 and x equals 1. I need to check to make sure that those aren't excluded values, and they're not. So those are both the solutions to this problem. Okay, we have one more that's very similar to this. Again, if you want to go ahead and try to pause this one and try it on your own, that would be a good idea. First thing you want to do is you want to factor, list excluded values, and find your least common multiple. Okay, hopefully you were able to factor and see that this fraction on the other side of your equation, equal sign, factored into x plus 3 and x plus 5. Now that you have them factored, you should have gotten excluded values of -3 and -5. Your least common multiple, you needed to account for every little factor of your fractions. So I have an x plus 3 that I needed, so I could cancel out the x plus 3 from my first and my third fraction. And I needed an x plus 5, so I could cancel those out from my second and my third fraction. So my least common multiple needed x plus 3 times x plus 5. So I multiply that to every single term. Now I'm going to cancel out factors where I can. Notice that on the right-hand side of this equation, all of my factors cancel out except for what's left on the numerator. So now I'm going to solve and bring these down. 2 times x plus 5 plus 4 times x plus 3 equals 5. Okay, we're going to solve for x. I do not have an x squared here, so I can go ahead and get x's on one side and all the numbers on the other side. Okay, so as I started to solve for x, I eventually got 6x equals 17. When I keep on simplifying that, I get x equals -17 over 6. That is not an excluded value, so I'm allowed to have that as a solution. Okay, so the last two examples are a little bit more challenging. You will see a few examples like this in your practice worksheet. You are using the same worksheet from the 3.1 video. I will post it again in the link with this video. But you are only doing problems 3, 4, 5, and 8. So hopefully when you finish all 4 of these problems, the entire worksheet will be completed. So you have problems that use cross multiplying and then problems from today that use the least common multiple. You will also be receiving a practice problem for a Google form quiz. Okay, I want you to solve this for x, take a picture, submit it on the Google form, just so that I can check your progress and make sure that you're understanding some of the content. As always, feel free to email me with any questions. Make sure that you guys have this stuff down right now, because we're going to be using all of the properties that we've been using the past few weeks as we look at some graphs and kind of explaining the characteristics of these functions coming up in the following weeks. Have a great rest of your day, and I hope you enjoy the rest of this week as well.